Good morning all. Today we are going to take the class on the topic data cube computation. Okay. So what is the data cube? Data cube means it is the combined view of the or method of or view the combined view of multi-dimensional matrix. These are called data cube. When a large data set is available, that data will be viewed or that can be arranged in a multi-dimensional matrix order that will be called a data cube. So data cube is another alternative name for the multi-dimensional databases or materialized views or OLAP or online analytical processing. So data cube computation is a powerful technique for analyzing and exploring multidimensional data. So it allows the users to perform complex analytical queries and that will be measure or analyze something and it will be get valuable insights from the large data set. Is it? So for the multidimensional data model, it contains three areas or three categories. One is dimension and one is measure and another one is cell. Dimensions represent the different perspective of the attributes. What are the attributes that are available in the data set that will be given in different perspective that will be displayed. That is the dimension means. Example is the time, location, product. Basis on these criteria, we can view the databases. That is the dimension means. Measure means it will be the numerical values or the calculation values. What the criteria which we need to analyze the data. That is the measures means. Such as sales, revenue, inventory levels, etc. Then cells means it contains the intersection of dimension and its corresponding measure value. That is the concept of cells. Each cell it contains a dimension value and it contains also the measure value also. So this is the combination of these both are called as cells. Then these dimensions and measures that will be elaborated in detail. That means dimension define the structure of the data cube and allow the users to navigate, how to navigate and how to analyze the data from different perspectives. That is the dimension means, measure means it will be the numerical analysis or the values calculation of the particular value and it will be analyzed and it displayed on the cells. Hierarchies means within these dimensions that will be enabled different operations like a drill down or roll up operation that will be discussed in later. So provide some different levels of or some different details of analysis that will be possible with the combination of dimensions and measures. That is means hierarchies. Then depends on the operations or how to manipulate the data in a data cube or how to manipulate large data sets to meet the corresponding customer's needs. That is the concept of data cube operations. These operations will help to select particular data from the data set and that will perform the analysis and it will be displayed some of the outputs or that will be filtered some of the output and that will be displayed. That is called a data cube operation. So there are dicing, drill down, roll up, slicing, pivot. These are the different operations that are available in the data cube operations. Okay. So the first one is roll up operation. In this roll up operation that will be perform some operations or aggregations in certain or different data attributes. It contains the same dimension. Which data contains the same dimension, all the data together or combined together, it will perform some operations or the aggregation concept. So for example, if the data cube displays a daily income of a customer, we can use a roll-up operation to find the monthly income of his salary. So we can specify or we can roll up the operation to find a particular dimension field. We can do the analysis in a particular dimension only. Drill down is another operation or the second operation. It is the reverse of the roll-up operation. So it allows that as the user to take a particular information from the large data set and it will be performed the analysis. So it means it zooms into more detail. It will concentrate on a single set. For example, if India is an attribute of the country column and we wish to see the villages in India, Then the drill down operation splits the India into states, districts, towns, cities, villages, and then display the required information only. So that is the concept of drill down operation. Then slicing is another type of operation that will be filter unnecessary portions. That will be avoid the unnecessary portions, and it will filter the only dimensions which a user or customer that will be needed, and choosing that particular dimension only that will be do the analysis. The separate set is displayed as the another list. So here the operation filters the unnecessary portions. Suppose in a particular dimension the user don't need everything for the analysis. That is the concept of slicing. So for example, country equal to Jamaica that will be needed for the customer. This will display only about the Jamaica, and that will display another list which contain other countries in the diamond or in the data cube or the country list. Is it? Then dicing is another operation, that is the next operation. In this operation, it will be perform a cutting operation. So multi-dimensional cutting is the name of dicing means. It performs that it contains, it filter or it will cut the certain range of information from the dimensions, and it will look like a subcube. That is, from the large data set in a data cube, it will be divide a range of values or filter or retrieve some range of values from the data cube that will be look like a subcube. So that is the operation of dicing. Only selecting a particular part of the dimension and the data that will perform the operations. That is the dicing operation. For example, the user wants to see the annual salary of the Jharkhand state of employees. Okay. Then pivot is the last operation. In this operation, it is the viewpoint of the operation. This is not the analysis method. We can view something from the data set or the data cube. It will be what will be the user want to see in the or in a complete data set, that is the year-wise data or a branch-wise data, or a how the branch versus item type that will be compared. So it will be basically transform the data cube in terms of view. So it doesn't change the data present inside the data cube. It only makes an important point of or the transforming the data cube in a particular viewpoint. That is the pivot data cube operation. Okay. Then what is the concept means materialized views and aggregation hierarchy. Materialized views means it will be the aggregation that will be pre-computed aggregation that will provide fast access to the data included in a data cube by using variety of queries. Aggregation means it will be different levels of detailed with the dimensions, and it will enabling to do efficient roll and drill down operations, and it will filter something and it will select some part of the data from the data cube, and it will perform different aggregation functionalities. For the performance optimization, these both materialized views and aggregation hierarchy combined together, it will perform much more better than in the data cube computation. It will be done individually, other than it will be done individually. So these are the concepts of materialized views and cuboids. What is called a materialized views, or what are called cuboids? Materialized views means it will be a pre-computed data cube that can be done to play the analysis of queries that will be improve the performance of the data cube analysis or computation. And materialized view in a data cube computation, it is a data set or a database which contains a large set of data. It will allow fast query processing and reduce the computational overhead. So, especially in the case of large data set, the data does not need to be recalculated every time when a particular data set will be filtered from the data cube. That is the concept of materialized views. Cuboids means different aggregation levels of a data cube. That is a combination of something that is called a cuboid. It is various combination of dimensions. We want to combine or integrate some dimensions together. That will be the name of aggregation. So this will be called a cuboid. Then cuboids in a data cube computation are multi-dimensional arrays that represent different levels of data aggregation within a data cube. That means each cuboid represents or corresponds to a specific subset of dimensions and summarize the data inside that subset, and it will form or integrate with the dimensions and perform some other analysis. For example, in a data cube which contains some dimensions such as time, location and product, the cuboid might aggregate the data based on the type, based on the location, and it can be ignoring the product dimension and aggregate time and location. That will be perform some analysis and that will be represented to the user. That is the method of cuboid calculation or cuboid means. Is it? So there are different strategies for the computation. That is, computation strategies means we can compute bottom up or top down, then hybrid method we can follow. Okay. Bottom up means aggregate data from the lowest level of granularity up to the higher level. That is the concept of bottom up evaluation. Then approach means it begins with the detailed data and aggregates upward to the higher levels. Then advantage is it is the effective use of data cube where most data or the population of data that will be available. Then it will be expensive data computation or the some of the sparse elements that will be available. These are the disadvantage of that. Then example is starting with the individual transaction data and aggregating to daily, monthly and yearly sales details. We want to find the total of the aggregate value of the separate dimensions. That will be the bottom up evaluation example or the strategy of the computation strategies example. Then top down means it starts with the highest level of aggregation and progressively it drills down. Whom it focus or it will focus some other data sets constantly. That is the content called top down strategy. So it starts with the highest level of aggregation and progressively it drills down to the final level. Advantage is it will be the efficient data cube computation. So where many cells are empty, so that will be avoided the empty cells and it will be only looked to the data deeply. That is the concept of top down approach. Disadvantage is it is less efficient than the bottom up approach. Example is computing the sales totals, so breaking them to down or breaking them to in separate parts and separate parts that will be evaluated first and again that will be aggregated to form a final one. That is the concept of top down. Hybrid means it combines the bottom up and top down approaches to optimize the computation. Then star schema benchmark. This is another type of strategy that it is the purpose. It means a benchmark for evaluating the performance of lab systems. That is online analytical processing. It contains some of the performance criteria or a benchmark. Based on this benchmark, that data cubes or the evaluation that will be taken place. Then it contains a fact table or it contains the data. In the concept of benchmark or the star schema benchmark, it will be the name. Fact table means it contains some of the data based on sales, and multiple dimensional tables, that means multiple dimensions are the time, customer, product. So this will be aggregated. So this will be analyzed both the information. It will be used a particular benchmark for the performance evaluation. So it will be helped. It is used to assessing and comparing the efficiency of different data cube computation methods. Then for optimizing the performance of the data cube computation, it needs indexing. That means efficiently organize the data forced to analyze or to the query process. That should be the fastest query processing method. We need to arrange data in a particular indexing order. Then partitioning means the data will be divided into smaller units and it will be a manageable unit, and with the method of parallel processing, data will be evaluated together. It will form the final result. Incremental maintenance means updated the materialized views, then data is added, or it will be avoid the full data cube concept. It will be maintained the incremental basis or update the materialized or the data cube as a separate viewpoint or a modularized method we can maintenance. That compression is, it will be reduce the storage requirements and improve the query performance. These are the performance optimization techniques. Then what are the different challenges in data cube computation? The first one is source of dimensionality. That means the number of dimensions increases, the size of the data cube grows exponentially. So this will be leading high storage and the computation requirements. That is the first challenge, curve of dimensionality. Then sparse data is another challenge. That means many in a data cube, in a large data set cases, many data cubes contain large amount of empty cells or a missing value. So it will be a challenge to efficiently store the data, or which data that will be stored. How we can efficiently store that data to process the data. That is the concept of sparse data. Then incremental maintenance, that is another challenge. So updating in a materialized views of cuboids when the underlying data changes can be computationally expensive. That means it consists, or it will make a two types of views, that materialized views or other than the cuboid. That means in a materialized view means it will be pre-computed the data, and the data cube will be saved like a pre-computed information that will be stored, and by querying it will make faster performance. Cuboid means the aggregation of the levels of data cube, and that will be presented inside the cuboid. So by using both these concepts, it will be a computational expensive for the maintenance of the data cube. That is the incremental maintenance. Scalability means handling large scale of data, and it will be either interactive data or real-time data. It will take or it needs to store much more data. That will be the scalability issue. So handling the large scale data is another issue. So to address these challenges, several best practices and optimization techniques can be employed. So these are the challenges: source of dimensionality, sparse data, incremental maintenance, scalability. These four are the challenges in data cube computation, and to address these challenges, we use some of the practices for optimizing these techniques. Okay, to remove these challenges. So first one is dimension reduction. So we can reduce the size of the data cube. So we can focus only some relevant dimensions, and we can streamline the data and simplify the analysis. Then compression technique, that means we can use different compression methods to minimize the size of the storage point of the view. So we can use different encoding methods or the different compression methods to reducing the size of the queue. It will be when dealing with the sparse data. So we can compress it, and it will be effectively make the mechanism to effectively use the storage mechanism or the size of the data cube. Partitioning and indexing means we can divide the data into module wise, and it will be managed parallelly. It will be processed, and the amount of data that will be accessed and analyzed, that should be a smaller. For each query, that can be easier to manipulate or managing. So by using effective indexing, we can map the data more effectively, and the query processing also it enabled faster. By using the indexing method, the data will be retrieved much more easier. So the partitioning method, it will be done easy, or query processing, that will be easier. Then materialized view selection, that means it contains or which is aggregation to materialize the content. It will be a crucial method for balancing the performance and storage requirements. So for the business method or business intelligence, we should prioritize most frequently accessed and computational data, or which expensive queries are there, that should be minimized or maximize the benefits of pre-computation. Already we pre-computed, and that will be stored in the database. For a performance evaluation or the analysis process, the pre-computed data will be taken, so that will be much easier, and it's much faster compared to the raw data that will be stored in a data cube. Then query optimization is another method. We can use advanced query methods, or query rewriting, or query caching. So it can improve the efficiency of both the pre-computed on-the-fly queries. So these techniques help in reducing the computational overhead of the data cube. Then efficient data structure is the another method. So array-based storage or a sparseness matrix representation can help to manage the data cube size and enhance the performance. So these data structures can reduce memory usage and improve the speed of data access. So by using efficient data structure for the data storage, that will be helpful to speed up the data access and query processing. Incremental and approximate computation. This means update only the changed part of the data cube can significantly reduce the overhead associated with the full cube manipulation. Additionally, approximate computation method means it will provide faster insights. It satisfies some of the fields, but it will be maintained or it will be acceptable much more effective results other than compared with the other method of computation, that is incremental and approximate computation. That will be the preferable method for to effectively manage the data cube in a particular or a certain application area. Then use of advanced technologies means using the advanced technology like in memory computing or distributed computing framework can enhance the scalability. So we can handle more data and it will be help to speed up the data cube computation. These technologies enable the handling of large data sets and real-time analytics, providing business with a timely insight. So these are the advantages of data cube: multidimensional analysis, interactivity, speed and efficiency, data aggregation, improved decision making, accessibility. These are the different advantages of the data cube. That is, that multidimensional analysis means data cube enables multidimensional analysis, or it contains a large data or business data, so allow users to view data from different perspectives and do the analysis. Interactivity means data cubes provide interactive access to the large amount of data, allows users to easily navigate and manipulate the data, and it will support the analysis easily. Speed and efficiency means data cubes are optimized for collapse analysis, enabling fast and efficient co-reading and aggregation of data. Data aggregation means data cubes support complex calculations and data aggregation. So it will be easier to summarize the data or aggregate the data and to easily to analyze the data. Improved decision making means data cubes provides a clear comprehensive view of the business data. It will enable improved decision making and business intelligence. Then accessibility means data cubes can be accessed from a variety of devices or platforms. It will be easy for the users to access and analyze data from anywhere. So it will help to summarize the view of data. So data cube can store large amount of data in a simple way. Data cube operations provide quick and better analysis, improving performance of data. So that is the advantages of data cube. Disadvantages of data cube means it will be a complexity. All our systems can be complex to set up and maintain, require specialized technical expertise. With the technical expertise only, we can manage the data or maintain the data. That will be the complex structure. Data size limitation means all our systems can struggle with the larger data sets. It may require expensive data aggregation or summarization method. Then performance issue means you can slow when dealing with a large amount of data. It will be slow down the query process of calculation. That will be the performance issue. Data integrity means it will be changing the method of analysis. The data definitions or data quality issues can affect the accuracy of the data stored in the OLAP systems or the OLAP analysis. Costly means it can be in a case of large data set or a business intelligence data, it can be expensive. For an enterprise level of solutions, it will need another specialized hardware or software for supporting to store this data. So that is the cost concept. Inflexibility means all our systems may not easily accommodate changing business needs, and it may require significant effort to modify or expand it or extend it. So it needs much more hardware support or a platform difficulties will be there. So that is the inflexibility of the data cube operation. So these are the data cube computation. It is a powerful mechanism. Data cube computation is mainly, data cube is the, when a large set of data we can have, it will can store the after the computation only we can store the data, while we can perform the aggregation operation effectively inside the data cube with using a fastest query mechanism, and we can have large data sets in a multi-dimensional representation. That will be that is the data cube. So data cube computation is means it is a powerful operation for compute or analyzing, how it will be aggregated, how it will be analyzed with a query mechanism. That will be called a data cube computation. Based on the data cube computation of the storage, based on the storage of data cube, the data cube will be operations, drill down operation is the roll up operation is the slicing, dicing, pivots. These are operations are involved in the data cube computation, and we can store the data as the materialized view, and also in the cuboid form we can store the data in a data cube. That have variety of advantages and disadvantages of the data cube, and this some of the challenges that are faced to implement the data cube or the data cube computation, that is curse of dimensionality, sparse data, or incremental maintenance and scalability are some of the challenges, and to optimize this technique, or we can to remove these challenges, we can have some of the overcoming or optimization techniques will be there. Is it? So these are the concepts of data cube computation. Okay, thank you.